Hello, good evening, students. So, today we will learn about three more extra topics related to the separation of substances. So, it's total 6 extra topics which are not included in your syllabus, but though it is very much related with this chapter, separation of substances. So, we have to learn all of these things, and in details, more and more details, you will learn about these separation processes in your higher classes. So just I'm gonna say shortly regarding the three extra process. First of all, separation by the magnetism, or you can say magnetic separation. So separation by a magnet. Actually, we know that iron is attracted by a magnet. This property of iron is used to separate it from a mixture. So, if a mixture contains iron as one of the constituent, it can be separated by using a magnet. For example, a mixture of iron fillings and sulfur powder can be separated by using a magnet. This is because iron fillings are attracted by a magnet and stick to it, but sulfur is not attracted by a magnet. So this will become more clear from the following discussion. Means whatever the discussions I am gonna say to separate the mixture of iron fillings and sulfur powder. So in order to separate iron fillings from sulfur powder, a horseshoe type magnet is moved on the surface of the mixture. The iron fillings are attracted by the magnet, they cling to the poles of the magnet and get separated. This process has to be repeated a number of times to achieve complete separation of iron fillings. Sulfur powder is not attracted by a magnet, so it remains behind. A mixture of iron fillings and carbon powder can also be separated by using a magnet in a similar way. And a mixture of iron fillings and sand can also be separated by using a magnet. A carpenter can also separate iron nails from sawdust by using a magnet. This is because iron nails stick to the magnet but sawdust does not. In industries, the impurity of iron present in several substances is removed by the use of magnets.
Hey, what is up, everybody? Today we are going to be doing magnetic separation. So here I have a magnet and I'm going to put it in the polythene bag. And now I'm going to try to separate the iron from the sand. Here you can see the iron has stuck to the magnet. And then when I take the magnet out of the polythene bag, as you can see, the iron falls in the bowl. Here I have a mixture of sand and iron. Now I'm going to perform magnetic separation. So what is magnetic separation? Magnetic separation is a technique in which metals which are attracted to magnet are extracted by using an electromagnet. For this experiment, we'll be using a plastic bag, a magnet, a paper plate, and a bowl with a mixture of sand and iron. So first I'll put the magnet in the plastic bag. So now I'll just hold the magnet center near the sand. Here I'm hovering the magnet so the ions get stuck to the magnet. Here you can clearly see the iron has stuck to the magnet. Then again I remove the magnet from the polythene bag so the iron falls down. And now you can see the difference. The iron has separated from the sand. Another way you can perform magnetic separation is, so now I'll put it in the paper plate. And another way you can perform magnetic separation is put the magnet under. Hey guys, be nice, like and subscribe. See you next time.
So students, today's our second topic is separation by chromatography. Separation process by chromatography. Chromatography is a technique of separating two or more dissolved solids which are present in a solution in very small quantities. There are many types of chromatography, but the simplest form is the paper chromatography. So we will study only paper chromatography in this class, for this class basically. By using paper chromatography, we can separate two or more different substances present in the same solution. This separation is based on the fact that though two or more substances are soluble in the same solvent, you can say like water, but their solubilities may be different. So you have to keep in your mind, in a water in water solvent, two or three substances can dissolve, but their solubilities may be different. Some may be more soluble than the others. For example, black ink contains a number of dyes dissolved in water. These dyes have different solubilities in water. This fact is used to separate the dyes present in black ink. It is most easy to perform chromatography experiment with the mixture of colored materials like inks and other dyes because they separate to give colored components which can be seen easily as colored spots on the paper. A special type of paper called chromatography paper is used for carrying out separations by chromatography. For ordinary purposes, however, filter paper can also be used for paper chromatography experiments. So black ink is a mixture of several colored substances or dyes, you can say, which can be separated by the paper chromatography method. So paper chromatography method is a practical method and one video is attached with it. You can see easily and you can easily learn from that process. So one thing I want to say, when the water reaches near the top end of the filter paper strips, in this process you can see properly. When you will see the process of chromatography, that time you will see water reaches near the top end of the filter paper strip. The paper strip is removed from the jar and dried. The paper with its separate colored spots is called a chromatogram. Now, what are the applications of chromatography? Chromatography is used to separate solutions of colored substances, dyes or pigments, you can say. Chromatography is used in forensic science to detect and identify trace amounts of substances like poisons in the contents of bladder or stomach. Chromatography is used to separate small amounts of products of chemical reactions.
In a beaker, we place about 20 ml of water. We cut 4 filter paper strips about 1.5 cm thick. In each strip, we form a line with a different color. Then we place the strips vertically in the beaker so that their bottom are weighted by the solvent. After some minutes, we can see that the pigments have been separated.
So students, today our last topic of extra topic, third topic, and it is also the last topic from this chapter we are going to learn. So this topic is separation by separating funnel. A mixture of two immiscible liquids can be separated by using a separating funnel. Immiscible liquids, already you know, the liquids which cannot dissolve in water properly, which cannot mix in water properly, are called immiscible liquids. So here we will learn about the process how we can make them separate very easily by this method. A separating funnel is a special type of funnel which has a stop cork in its stem to allow the flow of a liquid from it. In the picture you can see easily, or to stop the flow of liquid from it. The separation of two immiscible liquids by a separating funnel depends on the difference in their densities. Whenever two immiscible liquids have different densities, so that time you can segregate them very easily. So now a mixture of water and kerosene can be separated by using a separating funnel, and a mixture of petrol and water can also be separated by using the separating funnel. So we can separate oil and water mixture, because any kind of oil and water means oil can never be dissolved in water, so both are immiscible liquids, and oil and water have different densities that we know. So one or two process I will explain properly, then you can easily learn from this process how we can make them separate. So first of all, when the mixture of water and kerosene is put in a separating funnel, it forms two layers. Water, being heavier, forms the lower layer in the separating funnel, whereas kerosene, being lighter, forms the upper layer. On opening the stop cork of the separating funnel, the lower layer of the water comes out first and collected in a beaker. When the water layer has completely run off, the stop cork is closed. The kerosene is left behind in the separating funnel. It can be removed in a separate beaker by opening the stop cork again. A mixture of petrol and water can also be separated by using a separating funnel. Petrol and water are immiscible immiscible liquids. So they form two layers in the separating funnel, water being heavier and forms the lower layer, whereas petrol being lighter forms the upper layer. On opening the stop cork of separating funnel, the lower layer of the water comes out first and collected in a beaker. When the water layer has completely run off, then the stop cork is closed. The petrol is left behind in the separating funnel. It can be collected in a separating beaker by opening the stop cork again. So already two methods I have explained regarding this topic. So today up to these students, not only these two topics means or these two types of liquids, lot of things can be separated by separating funnel. So just two examples I have given. So today up to these students, thank you. Visit again.
Separating funnel. We already know about the evaporation and centrifugation, the two important methods of separating the components. There are several other important techniques for separating the components from several types of mixture. Can you tell how can we separate a mixture of two immiscible liquids? They can be separated by using separating funnel. But what actually are immiscible liquids? When the liquid does not dissolve in each other are called immiscible liquids, such as mixture of oil and water are good example of immiscible liquid, and a heterogeneous mixture are separated by separating funnel. Now, let's understand the principle behind the separation of two immiscible liquids. The principle is behind that it is used to separate the components from a mixture of two immiscible liquids, such as mixture of oil and water. In a mixture of two immiscible liquids, lighter one and heavier one form separate layers. This totally depends upon the densities of the two liquids. Now, let's understand this method by the help of an activity. So, the materials required for this activity are separating funnel, iron stand beaker. Now, let's do this activity through these materials. Let us try to separate kerosene oil from water using a separating funnel. Pour the mixture of kerosene oil and water in a separating funnel. Clamp the separating funnel on an iron stand and allow it to stand for some time. Open the stop cork of the separating funnel and pour out the lower layer of water carefully and collect the water in a beaker. Close the stop cork of the separating funnel as the oil reaches the stop cork and left behind in the separating flask. Now, let's discuss about the application of separating funnel. To separate mixture of oil and water. In the extraction of iron from its ore, the lighter slag is removed from the top by this method to leave the molten iron at the bottom in the furnace.